Picture handing someone your credit card and telling them to go do some research for you, not a person, a piece of software, an AI agent. It is fast, it is tireless, and it does not get bored. It also does not feel the little flinch you feel right before you spend money. That flinch quietly does a lot of work in your life, and the agent does not have it. This is a devlog about building the thing that has to stand in for that missing flinch. Quick context before the real story.spoolcast is my II video pipeline. It can start from almost any source material, a chat, a transcript, a repo, notes, or a story idea. .agents read the material, find the angle, write the script, build the shot list, generate the visuals, narrate it, and render the video. I am still directing it with feedback and approvals. I am just not editing clips on a timeline, which is a little on the nose today, because this episode is about giving agents room to act, and the limits you put around it. The product is called PipelineCPC. Is a tool for paid search keyword research. It helps you find which ad niches are actually worth bidding on. It runs on credits. Every keyword the research tool returns costs 1 credit. Credits are bought with real money. The task this session was to let AI agents use that tool on your behalf. You would create what is basically a long secret password and long TI key and hand it to an agent like Claude or Codex. The agent could then research keywords and draft ad campaign plans for you. The endpoints to do this already existed, so in theory this was a small job. It was not a small job. Before writing any UI, I stopped and asked one question. What is the worst thing this key can actually do? Not in a dramatic way. Literally, list the damage. A key can spend credits by fetching keywords. That is the entire risk. It cannot launch ads. It cannot change billing or cancel the subscription. Naming that boundary out loud decided everything that came after it. If the only real risk is spending, then every control I build should be aimed at spending. The guiding rule was simple. Fail closed. If a setting is unclear, it should default to the safe option, not the convenient one. Control 1. A key can read your already saved lists, which is free, or it can fetch fresh keywords, which costs credits. That fresh fetch switch defaults to off. A key you create without thinking carefully simply cannot cost you anything. Control 2. Spending limits at 3 different time ranges. A limit on each single request, a limit for each day, and a limit for each month. One number is not enough. A single runaway request and a slow, bad afternoon are different kinds of failure. They need different fences. Control 3. The key itself is shown exactly once. When you create it, you see the full secret one time, and the screen warns you plainly. The server only stores a scrambled fingerprint of it, a hash, never the real key. So even if someone steals the database, the real keys are not inside it. Lose your key, and the only option is to revoke it and make a new one. Before writing the real code, I built a fake version of the screen, a mock-up. Then I sent it to a second II model, Codex, for review.not to write code, just to look hard at the plan and try to break it. Codex came back with 3 required fixes. 1. The fresh fetch setting defaulted to off in the screen, but not in the server underneath. If a request just left that field blank, the server quietly treated it as on. The safe default has to live in the server, not just the screen. Fixed. 2. A key's name is typed by a user, and user types text can smuggle in code. Every name has to be made safe before it is ever shown on a page. Fixed. 3. Put a ceiling on how many keys one account can have. I picked 5. Codex also caught a small thing that would have quietly wasted everyone's afternoon. The setup instructions named the wrong setting. Copy it exactly, and nothing works with no error at all. Fixed. Then the code was written, and it passed every automatic check, and then a human clicked the buttons. Clicking generate key once felt slow, so I clicked it a few more times. It made a brand new key for every single click. I watched 5 nearly identical keys scroll past before the screen settled down. The button had no lock on it. Fixed. 1 click, then it disables itself. Next, my account balance was negative. I had overused the service myself, but the warning showed my balance as a positive number. A pattern meant to strip out commas was also quietly eating the minus sign. Minus 500 became 500. Fixed. Then the whole settings window grew taller than the screen, with no way to scroll. The buttons at the bottom were simply unreachable. And the final screen had 3 different buttons that all basically said, done. Every one of these passed the test. Not one of them survived a real person. Here's the part worth keeping. The integration, the actual connection, was the easy half. The endpoints already existed. The real work was the fences, deciding what the agent must never do and defaulting everything to the safe side. And fixing the things that only break when a real person, not a test, touches them. As AI agents start doing more for us, let the agent handle it quietly turns into let the agent spend. The interesting design problem was never the connection. It was always the limits.